Have you ever tried to polish silver in order to remove tarnish? It can be a lot of work with a physical polish, rubbing every square centimeter of surface. Some of you might know that you can also immerse silver in a hot solution of sodium bicarbonate, that is, baking soda, that also includes immersed aluminum foil. That's an example of an electrochemical process that can be described in fascinating detail using thermodynamics, but that is beyond the scope of this course, unfortunately. However, there's another approach that one might employ, and one that we already have the thermodynamic tools necessary to understand. The tarnish on silver is silver oxide. That is, there is a small layer on the surface of the silver where oxygen atoms have bonded to the surface to form silver oxide, which instead of being a lustrous metallic color is dark and opaque. Tarnish on silver can also be silver sulfide, but we'll ignore that complication here. Oxidation of silver in air at room temperature is driven by enthalpy. It is exothermic to react oxygen from the atmosphere with metallic silver to generate silver oxide. However, the process clearly is unfavorable from an entropic standpoint because free molecules of oxygen are removed from the gas phase and their atoms tied into the solid. Thus, at sufficiently high temperatures, we should be able to reverse the spontaneity of the reaction and use entropy to overcome enthalpy and drive silver oxide to become silver and molecular oxygen, thanks to the favorable entropic release of molecular oxygen. Let's see if that works. I have here a fabulously tarnished piece of silver. Pretty ugly, isn't it? But now I'm going to light this torch and try heating it up. Notice, as it's warming, getting hotter, I see oxide disappear and whiter metallic silver reasserts itself. Pretty, isn't it? Because this silver is rough and not polished to a uniform layer, we don't see the luster that we could otherwise achieve for metallic silver, but certainly the loss of tarnish is evident. Unfortunately, if I let it cool down in air, the reaction returns to its normal room temperature direction, and I end up with tarnished silver again. To avoid that, I'd have to put the hot silver into an inert atmosphere, that is, one lacking in oxygen, and let it cool. Of course, it will still tarnish at room temperature too, but the reaction is slower at the lower temperature, which is why people don't have to polish silver every day. So, if you have a torch and a box full of argon, now you know a simple way to polish silver. Or you might want to try that electrochemical trick instead.